Hey there everybody, and welcome back to our video on how to make your own fungible token contract. So the first step is to go to this GitHub link. The next step is to copy and paste everything, go into a Flow playground, paste it, and click deploy, and then you're done. No, so in this video, we are actually going to be going over how to make our own fungible token contract, but we're going to be doing it from the ground up. So if any of you have seen my non-fungible token video, you'll notice that first I sort of described what NFTs were, then I made my own NFT contract, and then I made it fit the standard. In this video, we're going to do it a little opposite. So first I'm going to explain what fungible tokens are, then we're going to actually talk about the fungible token standard on Flow, and then we're going to make the contract based on that standard. So the first thing I actually wanted to go over was what is a fungible token and how is it represented on Flow. So the first question is, what's a fungible token? So nothing to do with this diagram yet, but a fungible token is basically a token that can be interchangeable. So if I were to give you a $1 bill, and then I was like, you know what? No, you can have this $1 bill instead, right? You can do that because the $1 bills are the exact same, right? If I gave you a certain dollar bill and then I gave you a different one, and took the other one back, it wouldn't matter because they're both $1, right? They're both worth the same amount. Whereas a non-fungible token is not like that, right? NFTs are not interchangeable. They're unique in their own way. So we're going to be talking about fungible tokens, which means that really a fungible token is just represented by a number. It's just a value. So if I were to give you, $5, that's $5. And if I were to give you a different $5 bill, it's the same thing. And we're going to see how that is sort of reflected in Cadence. If you watch the NFT video, you remember that we actually represented NFTs as resources. And that's because resources are unique and NFTs are unique. And so it makes sense that you represent them together. But in the fungible token example, the fungible tokens are just going to be basically a number that are wrapped in a resource. And so that's what I wanted to go over here. So in Cadence, we represent fungible tokens as a vault. And so this is, in the diagram, this is sort of the vault. So let me just draw vault here. And you can imagine a vault is just a container of money, right? It's a container of fungible tokens. And so let's say this is Jacob here, right? Let's just write Jacob. And Jacob owns 40 fungible tokens. Then, we'll do a pointer to his vault. And let's say my vault has 40 fungible tokens in it, okay? Now, let's say that Jacob wants to give some money to Sarah. So what we're going to do is I'm going to say, you know what? I want to give 20 of my fungible tokens to Sarah. So what's going to happen is I'm going to say, okay, withdraw 20 fungible tokens from my vault. So let's copy and paste this. Go down here. And when I withdraw 20 from my vault, instead of this being a 40 right here, this is going to be, now we're going to withdraw 20 fungible tokens. And this is now going to get reduced to 20. And so a new vault is going to be created. So I'll just make this just more clear. So a new vault is going to be created that gets transferred to Sarah, and then we're going to deduct 20 from my initial vault. So in Cadence, everything is passed around in vaults, okay? So if I have 40 and I want to give 20 to Sarah, I take 20 out of my vault, create a new vault that has 20 inside of it, and I give that new vault to Sarah. And then Sarah will take this vault, which is this one that she's getting right here. Actually, I guess I already have it copied. So let's put it down here. And she will then put that into her own vault, which let's say she initially had 0, right? Now she'll have 20, and this vault will get destroyed. So let's just walk through that one more time. So Jacob has a vault that has 40 fungible tokens in it. I'm going to say, hey, I want to give 20 to Sarah. I'll deduct 20 from my vault, create a new vault that has 20 inside of it, so we're moving it. Sarah will take that vault and put it into her vault that initially had 0, and now it has 20 in it, and then we'll destroy the initial, like the vault that we were transferring here. So that's sort of what we're going to be doing. All right, so now let's actually get into some code and see how we're going to make this happen. So the first thing that you're going to want to do is go to this link. I'm going to put it in the description. And this essentially is github.com/onflow/flow-ft. And so this is sort of like the fungible token GitHub that the Flow team published. And so if we go to contracts and go to fungibletoken.cdc, this is the Flow Fungible Token standard. So we sort of talked about this in the NFT example, but let me just copy this over. So I already did this, but I'm just going to copy it over. and deploy this to account 2. So let's deploy this to account 2. And so to sort of explain what a standard is basically the Flow team saying, hey, if you want to have a fungible token on Flow, this is what it has to look like. And the reason they do that is because if you imagine things like OpenSea, right? When you put if any of you are familiar with like Ethereum, you don't have to be, and if this doesn't make sense to you, that's okay. But on things like OpenSea, which are NFT marketplaces, your NFTs have to have some sort of attributes associated with them in order for OpenSea to recognize them as an NFT. It's the same thing for fungible tokens. In order for the Flow blockchain to sort of recognize that this is actually a fungible token, you need to have a interface called Fungible Token, and this is the one that the Flow team uses. So if the Flow team were to have a marketplace or a platform that only uses Flow fungible tokens, your fungible token must implement this interface, and so that's what we're going to be using in this video. So let's actually go to our own page here. So this is account 0x01, and we're going to make our own contract. So public contract my token. So we're going to call our token my token. Okay, actually, we should make this more exciting. What should we call this? God, I'm not creative. Okay, we're just going to keep it as my token. I'm sorry for the lack of creativity here, but you sort of get the point. So let's go to the fungible token standard and sort of look at what it wants us to implement here. Okay, so the first thing inside of this contract, oh, and by the way, if you're not familiar with contract interfaces or just writing contracts or Cadence in general, you can check out the previous videos that I've done. I've done videos on everything that we're going to talk about in this one, but I'm still going to sort of explain stuff as we go just to sort of help out. So the first thing that this contract interface is saying is that our fungible token, which is my token, must have a total supply. So let's actually go to our contract and let's say we're going to have a public var total supply, and this is going to be a UFIX64. So our fungible tokens are going to be represented as a UFIX64, and then inside our init, it's complaining we haven't initialized it. We're just going to say self.totalSupply equals 0.0. Okay, so it's simple enough. We're just saying we're going to deploy the contract, and initially the total supply for our token is 0. Cool. That's all fine. So if we go back to our interface, let's skip the events for now. Let's skip all the resource interfaces for now. These are all just extra stuff we're going to add on later. So let's keep scrolling down until we get to something that's really important. And here we go. It's our vault. So the vault is the most important thing when you're talking about fungible tokens on Flow, because like I said, the vaults are where we're actually storing the money inside of them. And I'm going to sort of explain why this is really smart that the Flow team did this when we get later on in the video and we start exploring vaults. So this interface is saying, hey, we need to have a vault resource. And the first thing we're going to have in that vault resource is a balance. So just like I showed in this example, there's a vault, which you can think of as the resource, and the money inside of it right here, like this 20, that's the balance. So let's actually go into our contract. Let's make a new resource called vault. And inside of vault, we're going to have a public var balance. And remember, we're representing our balance as a UFIX64. So we're going to init this because it's going to complain if we don't. And we're just going to say that we're going to initialize it to self.balance equals 0.0, right? So that means that when this vault gets created, the initial balance is going to be 0. But let's actually look at what else this could be to make it more useful. So if we go back to our interface, I hate that we have to scroll down every time, but just stick with me here. So if we go to our vault here, it's saying, hey, actually, we want our init, so the thing that creates this vault, to take in a balance. So we're actually going to take in a balance and set our initial balance to that value, okay? So let's go back, and what we're going to actually do is take in a balance. So let's do balance, and this is going to be a UFIX64. And we're actually going to set our self.balance initially to the balance that we pass in, so that we can tell the vault, hey, this is what you want to create. And the reason that we're doing this, and the reason why this is important, is because remember, when we want to transfer tokens or something and we want to withdraw from our vault, we're going to have to tell the contract, make a new vault with 20 so that we can put that into Sarah's. And so that's sort of why we're doing this. Okay, now we want to do some other fun stuff. So in order to actually, work with this vault, we have to deposit and withdraw from it. So let's add a public function called deposit, and let's add a public function called withdraw. And so a withdraw is actually going to return a new vault. So this is going to return a vault, and let's open this up. And the deposit, we don't know what this is going to do yet. Okay, so all we know is that deposit is going to take in something, and withdraw is going to return a new vault that, if we want to give someone else tokens or something like that. So let's go back to our interface again. Scroll all the way down. I might have to figure out a better way to do this because this might be annoying. But we can see that withdraw, so we're going to do withdraw first, actually takes in an amount to withdraw. So it takes in a amount that is a UFIX64. And that's all that it's specifying here. And it's saying that it returns a vault resource. Okay, cool. And, there's some fun stuff here just to explain. So it's saying a precondition for this function is that the balance in this vault, so self.balance, has to be greater than the amount that we want to withdraw. And this is important because if we had a balance of 50 and we wanted to withdraw 100, that's a problem. And so this is going to panic if that's the case. And the post condition is this is the thing that runs after the function's over, says we want to make sure that our self.balance, so remember, this is after the function's over, so what the balance is after we already have withdrawn, equals the balance from before. Remember, the keyword before means the value of this before this function was called, minus the amount that we passed in. So if we initially had 50 and we wanted to withdraw an amount of 25, it's saying that now, 50 minus 25, which is the new balance, so 25 equals the before balance, which was 50, minus amount, which is 25. 25 equals 25, just as an example. Okay. So our withdraw takes in an amount, and returns a vault. So this is going to take in an amount, which is a UFIX64, and we want to withdraw. So let's actually return a new vault. So let us return. We're going to make a new resource, so create a new vault, and the new vault's going to have remember, the init function takes in a balance, so we have to pass in a balance of amount. And what this is going to say is, hey, when we withdraw, we want to return a new vault with the balance that we specified. So if we want to withdraw 20, let's return a new vault with 20 tokens inside of them. But of course, we also have to decrement this balance, right? So self.balance equals self.balance minus amount. So this is making sure that we actually correctly take the amount out of the balance out of our vault. And so this should be all good to go. And let me actually just check my sneaky notes on the side here to make sure that I didn't want to say anything else. Okay, awesome. So this is withdraw for now. Then let's actually go to deposit. So let's go all the way down to the deposit function, and let's see what's going on here. So deposit is right here, and deposit says that we take in the parameter is going to be called from. It takes in a vault, and the precondition is that this type right here from is instance of self.getType. So this is really confusing. I will explain this later on in the video, so just don't worry about that for now. But this is more important. This is saying that self.balance, which is the balance after we deposit, equals the balance before we deposited plus plus the balance of from when we deposited in. So for example, our new balance must be, the balance of from that we're passing in plus our, old balance from before. So let's actually do this as well. So we're going to deposit from, and we're going to take in a vault. And so what we're going to do here, it's going to say loss of resource. Remember, that's because we have to do something with this. And remember what I said in this drawing. We're going to deposit, so this is Sarah taking the new vault, passing it into her actual vault, and then destroying this resource right here. So that's what we're going to do here. So we're going to say self.balance equals from.balance plus self.balance, right? And so I guess it would make more sense if I ordered it this way, just because some people like to have it like this. But it doesn't really matter, right? So we're going to say, we want our new balance to be our old balance plus the one that we're depositing. Awesome. And then what we're going to say is we're going to say destroy from. And so this is making sure that we, get rid of that vault. We already, added its balance to our balance, so we are all good. Okay. Now, one thing that is really important is that when we actually deposit this vault, we want to make sure that it's of the type that, we are basically creating. So we want to make sure that this vault is a MyToken vault. And so the way that we can do that is we can make a new variable called letVault, and we're going to say this is from, so this variable, and we're going to typecast it to myToken.vault. And so what we're actually doing here is we're saying we want to make sure that the vault that's getting passed in isn't like ChrisCoin or Dogecoin. We want to make sure it's my token, okay? And so we do that by typecasting here. All right. And so then, of course, you know, because we've renamed it to vault, this is actually going to be vault, and this is also going to be vault as well. All right. Oh, and this also should have like the resource thing in front of it because, you know, whatever. And so right now it's going to say, hey, this always succeeds, but we'll see why we did this in a bit. Okay. And so the next thing we're going to do is, okay, so that's all good. Awesome. Now, here is the thing about resource or contract interfaces. So with a contract interface, you know, when we scroll down here and we look at our vault here, we're going to see that, you know, the withdraw here is returning an @vault, right? So a resource that has the type of @vault. And similarly, if we look at deposit, it's depositing an @vault. Now this type, this @vault, this is referring to the vault that's defined in this contract interface, right? It's referring, where is it? It's referring to this vault itself that's defined in this contract. And so in order to actually work with this interface, we can't just say @vault. We have to say @FungibleToken.vault. And so of course we're gonna have to import Fungible Token from the second account, which is where it's deployed over here. And so this is why we have to typecast it. It's because we have to say, hey, we're going to take in a Fungible Token vault, which is essentially any vault ever in the Flow ecosystem that abides by this token interface. And so that is required in order to fit with the spec, but you know, in order to make sure that this isn't some like random Dogecoin or something, that's why we typecast it to our vault specifically. All right, cool. And similarly, you know, we're not just going to return any old vault here. We're going to return a Fungible Token.vault here. And again, that's because, you know, we want to make sure that, you know, we're abiding by the interface. Now, it's going to give us an error here. And this is because, you know, this create vault here is returning a @vault type. But we want to return an @FungibleToken.vault type. And the way to do that is to actually officially implement the standard by putting this, you know, by making sure that my token actually implements the Fungible Token interface. And so once we do that, we're going to get a whole bunch of other problems here. And so we're going to explain that now. So the next thing is if we go back to our contract interface here and we scroll all the way down to vault, you'll see that I skipped over some things earlier. And the things that I skipped over was saying that the vault actually implements provider, receiver, and balance, which are defined above, up here. So balance just says that we need to have a balance. Receiver says that we just need to have a deposit function. And provider says we need to have a withdraw function. So remember what I said just now, that when this vault says it implements provider, receiver, and balance, these three are defined in this contract. So when we go back here, we have to say vault actually implements Fungible Token.provider, Fungible Token.receiver, right? This is it's a process for sure, and Fungible Token.balance. And so once we do that, our vault resource is actually good to go. Cool. Now it's going to still give us some complaints. My token does not conform to the Fungible Token interface, and we'll see why in a sec. So we haven't done some things that are necessary. So some of which are basically what we're going to be doing in this next part of the video is just trying to finish our contract to actually implement the standard. And so in our contract interface here, there are some events that are defined. So let's actually make sure that we bring those events over to our contract as well. And so I'm copy and pasting them, although I hate when YouTubers do this. So I'm actually, because it's annoying for the viewer to have to like try and figure out what I'm doing. So I'm just going to delete a bunch of stuff here and explain these individually. So we have an event called tokens initialized. And so this is an event that we will look at in a second here. So let me just make sure that I'm doing this right. Okay, yeah. So we'll do this in a second here. Tokens withdrawn. So you can imagine that we're going to emit this when tokens actually get withdrawn. So let's do that together. So in our withdraw function, let's actually emit tokens withdrawn. The amount is going to be obvious. That's just the amount that we passed in. And the from is an address question mark. And so the way that you do this is you say self.owner, self.owner question mark dot address. Dot address. Okay, cool. And so this is basically saying, you know, we want to return a address optional. And so the way you get an address optional is saying we want to get the self.owner, which is the owner of this vault, and then we're going to get the address of that owner. So that's who we're withdrawing from. And then we have one more event that's tokens deposit. So of course we can do that inside of here. So we're going to emit tokens deposited, the amount. And we're actually going to do this after we typecast it so that we don't emit an event by accident. So we're going to emit tokens deposited here. The amount is going to be vault.balance, and the to is just going to be self.owner, I can't spell, question mark dot, I can't spell, dot address. All right. So we've made sure that we have taken care of the events. Now it's still giving us some problems, so let's go back into our interface and see what we might be missing. So let's go back into here. We've done all this stuff. We've done the receiver. We've done the balance. And remember, with contract interfaces, you don't have to actually re-implement a resource interface, so we don't have to do any of that fun stuff. All right. So our vault wasn't giving any errors, so it can't be that. Now there's one thing left. And this is a function to actually create a new vault. So we should allow users to create their own vaults, right? Because they want to be able to store tokens. So let's actually implement this function, which is create empty vault, and this returns a vault resource. All right. So let's go back in here. Let's go all the way to the bottom, and let's make a public function called create empty vault, and it has to be the exact same name, remember? And this is going to return a @FungibleToken.vault. And we're simply just going to say, return create new create vault, and we're going to say, this function is to create empty vault, so the balance is just going to be 0.0. All right, and look at that. So our contract is ready to be deployed, which is super, super awesome. All right, so this contract that I am showing you on the screen right now is everything that is absolutely necessary to having a fungible token contract. There's no way of getting around this. Oh, and one more thing I want to say is that, right now, we're not really using this total supply, so it's kind of just blank at the moment. But I just wanted to show that this is sort of a base fungible token contract that can't really do much. And you may be asking, well, why can't it do much? It's because how can we possibly actually create some tokens here, right? Because right now, the only way a user can interact with this contract is to call this function. And this function returns an empty vault. So there's no way to actually create any tokens. And so what we're going to actually need is a minter. And so a minter is going to be the basically like the admin that actually makes vaults that don't have a balance of 0. Instead, they have a balance of whatever the minter wants to create it with. But I just wanted to get to this very basic example to show you that if you want to implement just the standard, this is all you would need in order to do that. Okay. So we are good to go. I'm going to take a quick breather here just to make sure I didn't miss anything I wanted to talk about. The pressure is on. Awkward silence here. But I think that this is all good. This is all good, right? Okay. Cool. Yeah. This is all good. Okay. So what we're going to say is basically we want to create a public resource named minter. And so a minter is going to have one job, to mint fungible token. And rather to mint fungible token that actually has, to mint a vault that actually has some stuff in it. So we're going to make a function here called public function mint token. And in here is going to be an amount to mint, which is a ufix64. All right, and this is going to return a fungible token.vault. And inside of here, we are going to return create vault balance of amount. And so all this minter is going to be doing is, oh, I misspelled return, is going to be returning a vault with the specified amount. Okay, awesome. And there's going to be nothing that's required in the init here because this says no state. Cool. All right, so did I do that right? I think I did that right. Yeah. Okay. So now one thing we have to remember is that when we actually mint token, right, we're actually we're quite literally creating fungible tokens out of thin air. And so we have to keep track of that somehow. And the way that we do that is with total supply. So when we actually mint tokens, we have to say that we want the myToken.totalSupply to be equal to myToken.totalSupply plus amount. So we want to update the total supply to make sure that we aren't like losing track of new tokens that are created. All right, awesome. And so this is good for now. So what we can do is, we want to be able to give this minter to somebody. So we don't want to make a public function to have just anyone allowed to mint tokens. We're actually going to give this minter to this account, like this contract account initially. So we're going to say self.account.save, and we're going to save a new minter, right? And to /storage/minter. Okay. So we're going to give this account the ability to have a minter. That way that this account, which is account 0x01, can go into their account, get the minter, and start creating new tokens. And we'll see how this works, right? All right, cool. So let's actually deploy this, and it successfully deploys, which we love. So let's go into a transaction now and start doing some fun stuff. So let's import my token from 0x01. We're going to go in here, and remember, if we are to access the storage of an account, we have to be in the prepare phase. So we're going to say let minter, and this is going to be equal to account.borrow. If you can hear, there's a really annoying trumpet in the background. Ugh, it's so annoying. Anyway, so we're going to borrow from /storage/minter. We're going to open up these brackets and say this is going to be of type myToken.minter. And, if we can't borrow it, then we're going to just panic here and say panic. We could not borrow the minter resource. All right, cool. So this is simply going to get the minter resource from the account, and then what we want to say is we actually want to, I don't know, let's mint a new vault, for example. So let's say let new vault. This is going to be a minter dot, let's say mint token, and the amount is going to be, I don't know, 20 or something. All right, and then we're going to log the new vault dot balance, and we're going to destroy new vault so it doesn't give us any errors, because remember, we have to keep track of our resources. So, if we were to sign this with account 2, it would panic because it says we cannot borrow, and that's because, remember, we only stored the minter in account 1, right? Because it's self.account, which is account 1. So let's make sure that we sign this with account 1. And you can see this, right? Okay, and so let's clear, and let's run this again. And look, so it logs 20. So it created a new vault, we logged its balance, and then we just destroyed it. All right. So why don't we now give people the ability to have their own vault? So let's keep this transaction for now. We're gonna name this like mint token or something. Let's save that. But we're gonna make a new transaction, and this is going to be called create vault. All right. So I'm just gonna copy and paste this code and get rid of like this stuff just so that I have like the base transaction stuff. And what we're going to see now is we're going to actually create a new vault and store it inside the person's account. So this is the equivalent of Jacob saying he wants to create his own personal account, or Sarah saying that she wants to create her own personal vault. It's that sort of thing. So we're going to say whoever runs this transaction, we're going to say account.save, and we're going to save a new vault to their storage. So in order to do that, we're going to say myToken.create empty vault. Remember, we made a function that just creates an empty vault, and we're going to save this to /storage/vault. All right, and so then we're just gonna, after we do this, we're just gonna log like I saved my own personal vault. Cool. So let's just run this from like account 3, I don't know, some random account, and let's send this, and it says I saved my own personal vault. So this account 3 now has their own account, their own vault. And so what we can do is we can actually run a script to actually read the balance of that vault, which we obviously know is 0, but let's just check to make sure. So we can import my token from 0x01. We're just going to need this type. We're not going to return anything. And we're just going to log the balance of their vault. Now, I forgot to mention that in order to actually read this balance from a script, we have to make sure that we publicly link this, right, through some capability in order for our script to get that capability and then read the balance of this vault. So what we'll have to do is we're going to have to say account.link and then specify the type. So the type is going to be a reference to myToken.vault. All right. And we're going to restrict it to one of the fungible token interfaces. So import fungible token from 0x02. Oops, 0x02. And we're going to say that we only want the public to read the balance. So how you can do that is you can say we're going to restrict this to fungible token.balance. And fungible token.balance, if you remember, if we go to the fungible token contract interface, if we look at the balance resource interface here, all it has is a balance. So pretty much all that's going to happen is if we just restrict it to this, then the public can only read the balance of our vault, and so that's fine. And so we're going to link this to /public/vault, and the target is going to be where it's currently stored, which is /storage/vault. All right. So we linked it to the public, and so let's just, because we already did this with account 3, let's just run this with account 4 just to test. And it says I saved my own personal vault, so good to go. All right. So let's go to our script now, and we're going to say let the public vault, and we're going to get the capability to that person's vault. We're going to say get account, and we're going to have to pass in an account here, so which is going to be address. So get account, which is the account that we passed in. Get capability. The path is /public/vault. Remember, that's where we just linked it to. And then we're going to say, this is how I like to do my spacing, .borrow. And remember, we're .borrowing what type? We're borrowing this type. So let's actually get this code. So my token.vault restricted to this interface. Put it inside of 2 brackets. And I have to remember to import fungible token as well. Fungible token from 0x02. All right, and then if we can't borrow it, we're just going to panic and say, like, could not borrow the public vault for some reason. Okay. Boom. Oh, oops. I didn't do that right. Okay, awesome. And then what we're going to do is just log the public vault. Oops. Public vault dot balance. Cool. So let's pass in account 4 because that's who we just made the link for. Execute this code, and it says 0, which we expected. So there's nothing in the vault, right? Which makes sense. All right. So now, instead of just having an empty vault, let's actually mint tokens into that person's vault. So let's go back to mint token. And remember, before we just minted tokens, and then we just destroyed the vault. But what we can do this time is we can actually deposit those tokens into our account 4. So let's actually add some parameters to this transaction. And we're going to pass in a receiver account. And this is going to be an address. And our receiver account in this case is just going to be account 4, right? The person that has the vault already. All right. And so in order to do this, we're going to have to get their, basically a public link to their vault that lets us deposit into their vault. So there's a lot going on there. But remember what I said before, when account 4 made their own vault, right, their personal vault, they then linked it to the public. And so what this means is that what they did was they linked their vault, but restricted it to balance. Now, the issue with that is that there's no way for us to deposit into that vault then. We can only read their balance. So we have to also add another restriction here, but this is sort of a restriction that's actually like broadening the scope a little bit to allow us to actually deposit into their vault. And so if we add fungible token.receiver, then we're adding the capability for a public user to do whatever is defined in receiver, which is deposit. And so what that means is that a minter can sign a transaction to mint tokens and then publicly deposit them into someone else's account. And you might argue, well, this is bad because, what if someone doesn't want everyone to be able to put tokens in their account? To which I would say, hey, if you want to give me some free money, give me some free money. So that's what we're going to be doing in this video. But if you want a situation where for some reason you want the account to also be a signer in the transaction to receive, then you would just get rid of this parameter and just add an extra signer here. But usually that's not how it's done on Flow. Usually a user allows someone to deposit publicly by adding this receiver here. All right. So what we can do then is, instead of destroying this vault and logging the balance here, what we can actually do is go here, and we can say let the receiver vault equals get account, which is the receiver account. I wish it was auto completion. Receiver account dot get capability to /public/vault. Then we're going to dot borrow, and the type in here is going to be my token dot vault restricted to fungible token dot receiver, so that we can actually receive some tokens. And then we're going to add a panic statement that says like couldn't get the public vault, sad face. Okay, cool. And so what's the issue here? Oh, I forgot to add a little thingy here, and I also have to import fungible token from account 2. All right. So then once we get their public vault, we can then say receiver vault dot deposit, and look at what's happening here, by the way. So if I say dot, look at the options that come up. So there is balance, there's deposit, there's get type, there's withdraw. But what happens if I put withdraw here? Member of restricted type is not accessible, withdraw. And that's because we restricted to fungible token receiver, it doesn't even know what withdraw is. And similarly, if we did like receiver vault dot balance, it also says member is not accessible, balance. What we would have to do is add the balance restriction here, but we're obviously not doing that. What we can do is add dot deposit, and there's no complaints, right? Yippee, there's no complaints, because we're saying that's allowed here. All right, and so the thing that we're actually going to be depositing is the new vault that we create. So we move it in with the arrow syntax, right? And the new vault is the thing that we're actually minting, and this is all cool. So, all right. So remember, this transaction is signed by the minter, which was account 1. It's stored in that contract, and the receiver account is going to be account 4. So let's also add a log here that says like successfully. Is that how you spell successfully? Deposited tokens into the receiver account. Cool. So let's put account 4 here. Let's send this transaction. I couldn't get the public vault. So why is that? Let's see here. So what is the problem here? What did I forget to do? Oh, did I forget to... This is weird. Oh, okay. For some reason, it just wasn't working for that account, so I tried to just reset the process and do it with account 5 instead. So I have short-term memory loss. I can't remember if we added this before or after we did the account 4 stuff. But anyway, I can't remember literally what I did 10 minutes ago. But so I'm just going to be using a new account now, which is account 5. And so account 5, link this to the public, and then inside here we use account 5, and it says successfully deposited tokens into the receiver account. So if we were to go to our script now and read our balance for account 5, we would see that account 5 now has a balance of 20, which you can see right here. So just to sort of walk through this process again, let's actually just redeploy this fungible token contract so that it resets all of our state. And so if we were to go back here and let's just use account 4 again, like I was using before, because I know that was a little confusing. If we do account 4, you'll see that it's actually going to give an error, right? And it's going to say, oh, we have to, I guess, refresh the page because the playground is buggy. Oh. Well, here we go. The playground making my explanations more confusing as always. The playground, for some reason, when you redeploy a contract, gets really buggy. So let's just excuse this. But let's actually go back, refresh this page again, and then do account 4. Look what it's going to say. It's going to give us an error, right? And this is because we just reset all of our state. So we have to remember to actually create the personal vault for this account. So let's sign the create vault from account 4. Let's send this transaction, saves its own personal vault. Go to our script, read the balance from account 4 that we just created, and it says 0, right? But if we go to mint token now, and we sign from account 1, and we do the receiver count as 4. This is the person that's going to be receiving the token. Send this. Successfully deposited. And now if we go back to our script, you'll see that account 4 now has 20. So boom, we have done it. So this is sort of like the main components that you're going to need when you're doing a fungible token contract. Now, it can get a little more complicated, and the reason for that is because some contracts like to add more functionality, and I'm going to show that now. But we're not going to actually do this together. I'm just going to sort of explain what some other contracts do. So I copy and pasted this from my side monitor here. So essentially, the GitHub link I was showing you earlier that had the fungible token contract in it. There's also, so this is the standard. They also gave an example token implementation. So if you wanted to, you could literally just copy and paste this code and just change the name to your own name if you wanted. Yeah, so I just copy and pasted this this code and brought it into account 3 here. And so let's actually just change some stuff. And let's walk through this together. So what they have in this contract is they have everything that we had, but they have some extra fancy stuff. And so that fancy stuff is, stuff like an administrator. So the administrator can create a new minter. The administrator can create a new burner, and a burner burns tokens, which can get kind of interesting. So yeah. Now one thing that there's one thing left that we have to do here. And that is to make sure that if a vault gets destroyed, that we actually, we actually take away from the total supply. So what happens when, for example, Jacob has 2 billion my tokens in his account, right? Because I'm super rich, only in my dreams. But let's say that I have 2 million tokens in my account, and I just decide, screw it, I'm going to destroy my vault. I hate it. There it goes, done. What we want to do is make sure that we decrement that amount from the total supply in a way such that Jacob doesn't have to manually do that. Now, what we can do is inside our vault, we can create a destroy function. And this is an automatic function that gets called when a vault resource is basically destroyed, or when a resource is destroyed. This function is always called. And we're going to say my token.total supply equals my token.total supply minus self.balance. So this is saying if for some reason we destroy a vault, then we want to take away from the total supply. Now, there's another problem with this, and so it's as a hint, it's in the deposit function. The problem now is that, let's say that Jacob has 40 in his account, right? And Jacob takes out 20, decrements 20 from his vault, so his vault now is 20, creates a new vault with 20, and then Sarah deposits that into her vault, right? That's in this deposit function. Now what's going to currently happen is Jacob will withdraw, take 20 away, but that 20 is going to go to a new vault, right? Which is fine. That vault is going to get transferred to the deposit function of Sarah's vault, okay? Sarah's vault's going to take it in and destroy it. Now, what's the issue with that? The issue is that Sarah is adding the balance to her account, but destroying the vault. And when she destroys the vault, it's going to destroy the balance of that vault. So if you really think about that, the net total supply is actually going to decrease by the balance of that transferred vault, which isn't good because we're taking that balance and we're putting it here instead. And so in order to get around that, you have to say vault.balance equals 0, 0, and then destroy it. And so this basically ensures that when we destroy the vault that's being passed back and forth, we set the balance to 0 because we had put that balance inside this vault's balance, and then we can destroy it and the total supply won't be affected. So I hope that that makes sense. And so let's redeploy this contract here. And the playground's buggy. My life is awesome. Redeploy this contract. Redeploy this contract. Yay, we are set. And let's quickly add another script to get the total supply so I can show you that this is being updated correctly. Copy and paste the script just for base stuff. We don't even need this. Okay, and we don't even need this. I probably would have been easier probably to do it myself. And we can just log my token dot total supply, right? So let's just log the total supply. Bam, it's 0 right now, which is all good. And so then if we were go to mint token, and we were to mint some token into account 4. Remember, we have to set up account 4 really quick. Let's just set up the account. Bam, mint token into account 4. Run this from account 1, as always. Clear. Successfully deposited. If we go to total supply and log this, it will say 20. Yay! Woo! 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 And that's that. So, geez, I keep meaning to end this video. I'm so sorry it's going so long. But the last thing, so if that's fine, that you can just end the video there. But the last thing I want to show you is how to actually transfer fungible token. So I hope this will be helpful. I hope that watching this video, I know it's so long, but I hope it helps to some degree. I'm really sorry if it didn't. But what we're going to do now is we're actually going to transfer tokens from one person to another. So let's add a thing here called receiver account. Oh god, receiver account. Okay, and this is it. Jeez, what is going on with me today? Receiver account, okay. And it's the address, and the signer is going to be the person actually transferring them, right? So the person signing is going to be giving them away to another person. So in this example, it's Jacob is signing the transaction, and Sarah's the receiver account. Okay. I still think that diagram is so funny, by the way. But anyway, so let's get, okay, so let signer vault equals account.borrow. From /storage / vault, and this has type, my token .vault. So we're not restricting anything. This is the signer's vault, and then we're going to get the receiver's vault. So we actually have already done that inside of mint token. Remember here we said receiver vault is we're getting the account. We're getting the capability to their public vault, and then we're restricting it to the receiver, so we can just literally just get this code and bring it back over to transfer, and this is the receiver vault. And then we can say receiver vault dot deposit, right? Oh, and we also want to say the amount that we actually want to transfer, so ufix64, and we're going to say that deposit. Now we're going to move a vault into it, and the vault we're going to be moving is signer vault dot withdraw. I forgot to add a panic here. So we want to panic, just in case it doesn't exist, and say couldn't get the signer's vault. Okay, signer vault dot withdraw, and we're going to withdraw an amount that is amount. Okay, cool. And so then we're going to say basically transferred my token. Cool. Is that how you spell transferred? Is it 1R? No, that looks more right to me, but someone help. Anyway, yes, so this is what's happening. So let's check the total supply. It's 20. Let's check the balance of account 4. Account 4 has 20, so account 4 has all the total supply. And we're going to create a new vault for 5. Okay, so let's just create a new vault for 5 because we're going to transfer to 5. Bam, I saved my own personal vault. All cool. Let's check just to verify account 5's balance, which should be 0. Okay, cool. Now let's transfer my token. So the receiver account's going to be 5. The amount's going to be 10, and we're going to send this from account 4, right? So please, OMG, so happy it worked. It says transfer my token, but that's the true test is to see if the total supply changed. So is it still 20? It's still 20. See, so we've done it correctly. And the script, let's just check each of the account balances. Let's check that account 4 has 10, and let's check that account 5 has 10. Bada bing, bada frickin' boom. Done. So that's a fungible token contract. Really sorry that went so long. I hope that was helpful. Yeah. And if you want to look at the example one that the Flow team did, that's the one I copy and pasted here. You'll see that they also have some extra stuff. They have like an administrator that creates new minters. So if you want to have multiple minters, you can do that. They also had it so like that the minter has an allowed amount they can mint in the first place. I didn't really bother with that. You could even set your total supply initially to a value, and you could store a vault inside the contract that has that initial, value. Blah blah blah. You get the point. Anyways, that's it. Hope this was helpful, and I will see you in the next one. Bam.